Let's cover this problem. If you recognize in this problem, there's a couple of ways of factoring. The first thing with factor, I'm going to look for a greatest common factor. 6, negative 23, 12, and 20. Those constants don't have anything in common, and I don't have a commonality of x in there, so can't do that. The next thing I'm going to look for is if there's 3 terms. 1, 2, 3. There's not 3 terms. I can't take out GCF, so I can't use Xbox for now. Factoring by grouping, I do have 4 terms, 1, 2, 3, 4, but factoring by grouping only works if in the first 2 terms I have a GCF. There's not. There's an x squared. But over here, there is no, the GCF here would be an even, so maybe like a 4. But again, what's left would not have anything in common with this one, so I can't do that. So I'm going to have to use the rational roots theorem. The rational roots theorem says take the last term, factors of 20, and you take the first leading term, so I get factors of 6. So my factors of 20 are what?
1,
2,
4, 5, 10, 20.
and the factors of 6?
1, 2, 3, 6.
So then here, now you're actually going to go through and make all these fractions, right? So systematically go through it. So I'm just reviewing a problem we did last week.
1.
So let's just do all the numbers over 1, okay? What are those numbers, class?
1, 2, 4, 5, 10, 20.
Okay. Now we're going to do we're going to do all these numbers over 2.
Half, or 1 half.
So 1 over 2.
1,
So 2 over 2 is 1.
2. 5 over 2. 5 over 2.
So 10 over 2 is just 5. And then 20 over 2?
10.
Oh wow, look at all this. Okay, now we're going to do all these numbers over 3.
Over 1/3. 2/3. 4/3. 5/3. 10/3. 1/3.
And the last one?
1/6. 1/3.
2 over 6 is 1/3.
2/3.
4 6 is 2/3.
5 over 6. 5 over 3. 10 over 2.
Ooh-wee. That's a lot of them, right? Alright, let's go ahead and cancel some of those.
1 and 2.
Okay, 1 and 2.
10, 5 and 10.
So we're crossing off all the duplicates.
2 over 3. Then just go to the last line and cross out 1/3.
2/3. Whoops. I crossed off too many, huh? We're just crossing off one, not both. 1/3.
10 over 5/3.
10 over 3, 5 over 3.
10/3. 5/3.
The last 2. Oh, that's it.
We're okay?
Yeah.
Count with me. Ready, set, go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You skip over the circle one.
Oh. 16.
So
And then
just
16 times 2 is
32.
32 possible rational roots. Let's try something. Someone tell me a number to pick.
2.
Someone said 2. So now I'm going to use synthetic. I have 6, negative 23, 12, and 20. Bring this number down. Class multiply, what do you get?
12. Negative 11.
Add down. Now multiply.
Negative 22.
Add.
Negative 10.
Multiply.
Negative 20.
Add down.
0.
What does the remainder of 0 tell us?
That it can be factored.
Factor.
Oh, I'll show you with our calculator later. Now, if this is a factor, we're going to bring this down. Should I write x plus 2 or x minus 2?
X minus 2.
And then what am I left with?
6x squared, take away 11, x take away 10. 5.
Remember, that is one less degree than what we have here.
Yeah.
And then again, I'm going to see if I can factor that. Use the Xbox method. You could just use the Xbox method. A times C class?
That would be negative 16.
B value?
That would be negative 11.
Two numbers that multiply.
Negative 15 and 4.
15 and 4.
Yeah, well, negative 15 and then 4.
One of these has to be negative. So now with these two numbers, I have negative 15x and 4x. And now I'm going to put in 6x squared, and negative 10 is my last. Class, what's your GCF of this row? 2x. How about here?
3x.
GCF here?
That is
2.
yeah.
Positive. And this way.
Negative 5.
So now I can just write those. 2x minus 5. And 3x plus 2. Raise your hand if you got that. Alright, so let's use technology to make our lives a little bit easier with synthetic division. You had how many to test?
We had like 32 tests.
32, that's a lot, right? So if I put into my calculator, I'm just going to, someone has suggested just use a table, so I'm just going to put in this, if I allow you to use calculators. 6x to the third minus 23x squared plus 12x plus 20. And if I change my table set, so second window, I want it to ask me, right? And if I put in 2, what do I expect it to be? What was my remainder if I put in 2?
0.
0.
Why won't you put 0?
That's it. Then that's a factor. So if you're actually testing this, and if I allow you to use a calculator, which I may or may not, you have this whole list here. You can just start putting in numbers. 1. There's a remainder of 15. Negative 1. There's a number. Negative 2. Doesn't work.
You could use negative 2.
5 halves. Right? If I choose 5 halves, 5 over 2. Do you see it? It popped up 0. So, of course, on a free response, you're going to show me the work. Does that make sense?
Yeah.
But I'm showing you with the calculator as an opportunity to check your answers. Okay?